अच्छा बेटा, today is 3rd March 2026 and we are solving this question in the last class. It is January 2020 paper, question number 15. We have solved its part B in the last class, and today we are solving the last part of this question. And the question is, sir, we are given wavelength, sir, we are given time period, and whenever we are given wavelength and time period, then obviously we can calculate the speed of the wave. So the speed of the wave is the product of frequency and wavelength. Sir, we are given time period. So I am converting frequency into time period. Time period is 14.8 and the wavelength is 342. And if you use calculator, then you can calculate speed, and the speed of the wave is 23.1 meter per second. 23.1 meter per second. Okay. And we have full faith in this formula because this is very old formula. We have been using this formula since IGCSE classes. So we have no any doubt in this formula. And we have calculated the speed of the wave by the old formula. And we have full faith in this formula. Okay. And now we are going to use a new formula. We are going to use a new formula. So new formula is under root G is 9.8. Lambda, sir, lambda is 342 divided by 2 pi, and pi is 3.142. Pi is 3.142. And when we calculate speed of sound by this new formula, then it is quite interesting. The result is same. The result is same. You can solve yourself. Then the result is same. So, but as we have full faith in this formula and we have no doubt in this result, and now we are checking a new formula, and when we put values in this new formula and the result is same, then I can say, sir, this new formula is also correct because the result calculated by new formula and our old belief formula is same. It means this new formula is correct. And if this new formula is correct, then its condition will also be correct because this condition is related to this new formula. So now I am using this condition. So the condition is depth of the water must be greater than wavelength divided by 2. And when you divide 342 by 2, then the result is 171. And this result 171, it shows that the depth of the water, the depth of the water, the depth of the water is greater than 170 meter. Yes, it is 170 meter. So yes, it is confirmed. It is confirmed. We have showed that the depth of the water is greater than 170 meter. Sir, how is it possible? So, sir, we have discussed the whole theory in before the recording as well. Okay. So this question is completed and Manahil has missed the theory before recording. So खैर क्या क्या कर सकते हैं? So this question is completed, beta. And now we are solving a new question. And the new question is very simple. What is meant by refraction? And you know we are not dealing theories right now because refraction theory is very simple. I will explain all the theoretical question as well. Okay. But right now I am not writing the answer of refraction. And now this is the mathematical part of another question. The question is January 2021. Okay, beta? This is January 2021 question. January 2021 question. The question is, beta, sir, we have to calculate refractive index of water in the cup. We have to calculate refractive index of water in the cup. Okay. Sir, how can we calculate? So for this calculation, you need angle I, you need angle R, and how can you calculate angle I and angle R? So I am explaining. Sir, in this question, sir, we are given right angle triangles. If you consider this right angle triangle, this length is 3.7 centimeter. Sir, this length is 4 centimeter. This is 4 centimeter, and this is 3.7 centimeter. So you can calculate this angle, which I am calling theta. I am calling theta, okay? Or I am calling x, because my calculation below this picture, I am taking this angle as x, okay? So if I ask you to apply trigonometry, then you know this is opposite side, this is adjacent side. So if you apply tan theta, then tan theta is equal to opposite side divided by adjacent side, that is 3.7. And then you can calculate this angle x. And when you calculated this angle x, then 90 minus x will be angle I. Okay, beta. So, beta, Bunny, can you calculate first angle x? Tan inverse 4 upon 3.7. Tan inverse 4 upon 3.7. Bunny, beta, what is x? 47.2. But we need I, and this angle I will be equal to 90 minus x. And if you do 90 minus x, then what is the angle I, beta? 42.7. Okay, 42.8. Okay, okay, okay. Okay, okay, no problem. So angle I is calculated by using triangle method. Angle I is 42.8. Okay. And now I need to calculate angle R. Sir, for this angle R, you can use this right angle triangle. Sir, in this right angle triangle, sir, this side is 3 centimeter. This side is 1.8 centimeter. And again, opposite side divided by adjacent side, you can use tan theta. And when you use tan theta is equals to 1.8 opposite side divided by adjacent side, then you can calculate angle R. जी बेटा, what is angle R, Bani? 31.0. So angle R is 31 degree. So in this way, sir, we have calculated angle I, we have calculated angle R. So now we can calculate refractive index. So refractive index is equal to sine I is 42.8 divided by sine R is 31 degree. And then you divide these numbers, then the refractive index of water is 1.33. Refractive index of water is 1.33. But if you have noted, जी बेटा, noted? Okay. So this question is completed. And now another question. And this question is already written form, so we can discuss this question. In the last classes, I taught you this theory. Consider this is a glass block, and if in this glass block light or any wave enter at 90 degree, then there is no change in direction. The question is why there is no change in direction when the light incident or the wave incident at 90 degree. So I explained you the answer. The answer is consider these are wavefronts. Consider these are wavefronts. When this wavefront cross the boundary, then the left edge and the right edge, both edges, left edge and the right edge, both edges or all the points on the wavefronts, they are in phase and they are crossing the boundary at the same time. And when they enter into another medium at the same time, then all points on the wavefront they slow down simultaneously. And when they slow down simultaneously, then they cover same distance. They cover same distance in the denser medium. The right edge, the left edge, and all the points on the wavefront, they are entering, they are crossing the boundary at the same time. So they remain in the same line. And when they remain in the same line, then there is no change in direction. Then there is no change in direction, no deviation in the path. So if you read the answer from the marking scheme, wavefront is the line on which all points are in phase. Yes, sir, we know the definition of wavefront. Wavefront is an imaginary line which joins all the points which are in phase. Consider this wavefront, sir, crest, crest, crest. Sir, all points are in the crest form. All points in the same phase. Okay, sir, it is the definition of wavefront. Okay. And now, when a wave entering or crossing the boundary, then consider this is the boundary. This is the boundary, and this is the wavefront. This is the wavefront. Now you can say wavefront is parallel to the boundary. Boundary I have drawn with blue color, and the wavefront is red color. Sir, they are parallel. They are parallel. Sir, when they are parallel, so all the points on the wavefront, all the points on the wavefront enter the glass at the same time. All the particles, all the points on the wavefront, they are crossing the boundary at the same time. And when they are crossing the boundary at the same time, then they slow down in the glass block simultaneously. All the points slow down at the same time. In this way, the whole wavefront travel the same distance in the same time. So the ray does not change direction. So the ray does not change direction. So if you memorize these blue underlines, then you will be awarded 4 marks. And this question they ask again and again. So you must memorize this concept, must memorize this theory. And we have discussed this theory in the last classes. When a ray crossing the boundary at 90 degree or perpendicularly, then all the points on the wavefronts are parallel with the boundary. They cross boundary at the same time. They slow down at the same time. In the same time, they cover same distance in the denser medium. So there is no change in direction. So I hope you must memorize it. Okay. बेटा मैं पानी पी रहा हूँ फिर आगे चलते हैं कितनी देर में बेटा अगर आप इस क्वेश्चन को रीड कीजिएगा इस क्वेश्चन को रीड कीजिए प्लीज Sir, in this question, if you ignore the story, if we ignore the story, the question is, sir, this is the incident ray. This is the incident ray. And this ray is entering into water droplet. And the question is whether this ray will emerge out from the boundary or there will be total internal reflection. This is the question. And sir, how do we decide it? So I am explaining. Sir, we are given the speed of light in water, and we already know the speed of light in air. So, sir, we should first calculate the refractive index of water. We are calculating refractive index of water. Sir, speed of light in air is 3 exponent 8. Speed of light in water is 2.25 exponent 8. And if you divide these numbers, then obviously you can calculate refractive index. And the refractive index of the water is 1.33. So by using this information, so first we calculated the refractive index. Okay. And now, and now I am working on this normal. I am working on this normal. So on this normal, the incident angle is 40 degree, and I do not know what is angle R. I do not know what is angle R. So sir, if you use this formula, sine I divided by sine R, and you know the refractive index. So refractive index is 1.33. Refractive index is 1.33. Then obviously you can calculate angle R, and we are not wasting your time. So angle R will be 28.9. So the easy part of the question I have solved. I have solved the easy part of the question. I have calculated refractive index. I have calculated angle R. And now the question is at point X. And now I am asking Zainab. Zainab beta, at point X, at point X, they are asking whether the light ray exhibit total internal reflection or refraction. I do not know. They are asking whether the ray leave the water droplet at X or not. We have to decide. So what should we do now for point X? Consider this point is Y. We have done all work at Y. हाँ जी, Zainab बेटा बोले, what will we do at X? Okay, and how do we calculate angle at point X? I mean, they are we should calculate this angle. I think this angle, na, this angle. जी, how do we calculate this angle? No, 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 no. जी बेटा Manahil, if I call this angle as theta, then how this theta will be calculated? Manahil बेटा, how do we calculate this angle theta? और जैनब आपकी वाली बात भी है, अभी हम उस पर काम करेंगे. वी विल कैलकुलेट क्रिटिकल एंगल एज वेल, एंड देन वी कैन डिसाइड कि जो थीटा है वो थीटा क्रिटिकल एंगल से कम है या ज्यादा है. आपकी बात सही है. वी विल कैलकुलेट क्रिटिकल एंगल एज वेल, बट राइट नाउ फर्स्ट वी शुड नो व्हाट इज द वैल्यू ऑफ थीटा. मनाहिल जल्दी से बताइए, क्या कोई आइडिया आता है दिमाग में? हाउ डू वी कैलकुलेट थीटा? ओके ओके, सोचें. एंड रिमेंबर दिस इज spherical droplet, or we can say it is a circular droplet. And you know, in circle, radius is always constant. Radius remains same everywhere. Radius remains same everywhere. हाँ हाँ, दोबारा बोले बेटा, आपकी आवाज कट गई. 40. अच्छा जी. अच्छा बेटा जैनब, आप एंगल बता सकते हैं कितना थीटा है? फिर मैं एक्सप्लेन करने जा रहा हूँ. कोई भी नंबर बोल दीजिए. 40, ठीक है, मनाइल का आंसर 40 है। आपके जहन में बेटा कोई नंबर आ रहा हो, नंबर बोलिए। 80। अच्छा जी, अब जरा इसका आंसर सुनिए। आंसर बेटा ये है, सर वी कैन कंप्लीट अ ट्राइंगल by the radius of the circle, and now it is an isosceles triangle. This side and this side are equal, and you know, if the two sides of a triangle are equal, then angle opposite to equal sides will also be equal. The two sides are equal. This side is radius of the circle, this side is the radius of circle. So it is an isosceles triangle, two sides are equal, so the two angles will also be same. So theta will also be 28.9. Theta will also be 28.9 because radii of the circle is same. Okay, beta. So in this question, this is the technical thing which I have explained. And now we triangle. अब ये बेटा मुझे नहीं पता 40 डिग्री कहाँ पे दोबारा आएगा, ये मुझे नहीं पता, लेकिन मुझे ये वाली बात तो बिल्कुल सिंपल सी मुझे नजर आ रही है ना बेटा, कि दिस रेडियस एंड दिस रेडियस आर इक्वल, एंड इफ दिस रेडियस आर इक्वल, if this radius are equal, then angle opposite to the equal sides will also be the same. So theta and r, refracted angle will be the same. Refracted angle is 28.9, so theta will also be 28.9. अरे बेटा थीटा मुझे मिल गया 28.9, so now I am going to calculate critical angle, and you know critical angle can be calculated by this formula because we have calculated refractive index. So critical angle is equal to sine inverse 1 upon n is 1.33. Critical angle is equal to sine inverse. This sine turns into sine inverse 1 upon 1.33. And when you solve it, then what is the value of critical angle? So the value of critical angle is 48.8. 48.8. And this angle is much, much greater than incident angle. Incident angle is just 28.8. So I can say as incident angle is less than critical angle. Incident angle is 28.9 and critical angle is 48.8. So no total internal reflection, no total internal reflection. So the ray leaves the water at X. So there is no total internal reflection. So the ray will emerge out. It is the original path, and I think it will bend away from the normal. So the ray will emerge out from the droplet. So this question is completed, and the most difficult part of this question, I believe, and this theta, yes, this theta and this angle R are equal. This is the most difficult part because the two sides are equal, so their angles, opposite angle will also be equal. Okay, so this question is completed. And now we are solving another question which is from January 2022. January 2022. The first part of the question, what is the difference between transverse wave and longitudinal wave? So, sir, this is very basic question. In transverse wave, particles vibrate perpendicular to the wave motion. In longitudinal, particle vibrate parallel to the wave motion. So, very simple. And now this is the main question. The question is of 1 mark, 1 mark question. Okay, why incident ray not changing path? Why incident ray does not change direction? Why incident ray does not change direction? So the answer is when ray strike normally on the boundary, then incident angle is 0 degree, no change in direction. Incident angle is 0 degree because incident angle is measured with normal, and this ray is also traveling along the normal. So angle I is 0, so no change in direction. It is a 1 mark question, so we are not giving explanation. कैपेसिटेंस से पढ़ना इलेक्ट्रिकल जरूरी है इधर कैपेसिटेंस आ जाए कैपेसिटेंस से पहले इलेक्ट्रिकल पढ़ना जरूरी है नहीं आप कैपेसिटेंस कम हो जाएगा When ray strikes normally on the boundary, angle I is 0, no change in direction. And now we are solving a mathematical question. The refractive index of the glass in prism B, you are given. The refractive index of glass in prism B is greater than refractive index of glass prism A. Okay, sir, we are given their values. We are given their values. Refractive index of B is greater. That is why you can see the prism B is darker and prism A is less darker. Okay, and now what is the question? The question is complete the diagram to show the two paths taken by reflected and refracted light until they have returned to the air. When the ray of light reaches the boundary between the prism, some light is reflected and some light is refracted. Okay, sir, you are given this condition. You are given this condition. This is the boundary. This is the boundary, and I am coloring this boundary with green color. This is the boundary, and on this boundary, you are given this condition. Sir, at this point, light is refracting as well as light is reflecting. You are given condition now. The light is reflecting as well as light is refracting. So we have to draw both ways. So let's start. It is a drawing question. It is a drawing question. Sir, if um, we are drawing a reflection or refraction, first um, we should draw a normal. Normal means 90-degree line. So you must place protector at this point and then draw a 90-degree normal. Then draw a 90-degree normal. And this normal on the green boundary. So you have to draw, okay? You have to draw with measurement, with protector, with protector. So you will use protector and draw a normal 90-degree line on the green line. And now measure this angle. Actually, this angle is angle I. This angle is angle I. Okay, beta? And in the marking scheme, it is written, so this angle is 30-degree. So you should not see the answer from the marking scheme. You should measure by drawing. So the angle I is 30-degree. And if angle I is 30-degree, then this blue line is the incident ray, and you should draw reflected ray at 30-degree, at the same 30-degree. This is incident ray, and this is reflected ray. This is reflected ray, and this reflected ray is at 30-degree. This refracted ray is at 30-degree. And now again, you should draw a normal at this point. You should draw a normal at this line. And now You have two choices. Choice number one, you may consider, sir, here will be total internal reflection. If here is total internal reflection, then the ray will be drawn like this. If there is total internal reflection, ठीक है जनाब? अच्छा, sir, how do we know, sir, here will be total internal reflection or not? So, sir, we are given refractive index of prism A is 1.40. 1.40. So, calculate critical angle. Sir, critical angle will be sine inverse 1 upon 1.4. Ji, but can someone tell me what is refractive index in prism A? Sorry, what is critical angle for prism A? 45. Okay, but it is 45. Okay, and as you are drawing with measurement, then you should measure this angle. You should measure this angle. And this angle, consider I am considering this angle as x. Then according to the marking scheme, this x is greater than 45 degree. By measurement, you will measure this angle x. And according to the marking scheme, sir, this x, when you measure, sir, it is greater than critical angle. So there is total internal reflection. There is total internal reflection. And you know, if there is total internal reflection, then this angle will also be x. This angle will also be x. And at this point, at this point, again, I am drawing a normal. And now this angle is very, very small. This angle is very, very small. It is less than 45 degree. So further, no total internal reflection. So the light will leave the glass block, but bending away from the normal. Bending away from the normal. Ya Allah. Huh. So if you draw this diagram with measurement, then you can understand this question. Otherwise, बस मैं बोल रहा हूँ और आप सुन रहे हैं. So if you print out this page and if you measure these angles accurately, then you can draw it properly. And I know that Manahil can print out these pages, and I hope that she will print out and measure properly angle and share me its proper drawing on WhatsApp. ठीक है बेटा, मनाइल आप बना के देखिएगा ताकि हमें पता चले कि ये वाले एंगल कितने आ रहे हैं. अच्छा जी, ये तो हमने बात कर ली इन प्रिज्म ए. वी हैव डिस्कस्ड. जी जी. वी हैव. चलो चलो, कोई बात. ओके बेटा, ओके. अच्छा बेटा, नाउ वी आर वर्किंग इन प्रिज्म बी. सर, इन प्रिज्म बी दिस इज द ओरिजिनल पाथ, but as it is given the refractive index of prism B is greater, so the light ray will bend towards the normal. Bend towards the normal without measurement. Without measurement. Okay. And when the ray incident or strike at this boundary, then obviously it will emerge out into the air, but bending away from the normal. Yeah, Allah. So this drawing is completed and it is a 4 mark question for drawing. और कोई बहुत पुराना सवाल भी नहीं है बनी. ये सवाल भी 2022 का है. मैं ये नहीं बोल सकता ये उल्टा सीधा सवाल है, छोड़ दो. कहाँ से उल्टा सीधा है? 2022 का है. ठीक है ना? तो यू शुड ड्रॉ एंड यू शुड अंडरस्टैंड कि हमने क्या करना है इसमें. So this part is completed and the next part I think we will solve tomorrow. अच्छा, इसके अंदर for the part third, calculate the angle of refraction as this ray of light travel across the boundary between prism A and prism B. Okay, so in the last part, they are asking to calculate this angle. They are asking to calculate this angle. Okay, and this angle is calculated in the third part. It means कि you do not need to measure accurate this angle. ठीक है ना, इस एंगल को एक्यूरेटली मेजर करने की जरूरत नहीं है. बट इफ वी कंप्लीट दिस क्वेश्चन देन आई थिंक इट इज बेटर. सो सर यू नो we have a Snell's law. N sin theta is equal to n sin theta. This is for prism A and this is for prism B. Sir, in prism A, refractive index is 1.4. In prism B, refractive index is 1.55. Sir, we are calculating angle of refraction. We are calculating angle of refraction in prism B. And what is angle I in prism A? As I said earlier, sir, this angle must be measured because without measurement, this angle, without measuring this angle, you cannot draw these lines as well as you cannot calculate angle R as well. So this angle is 30 degree. This angle is 30 degree. You have to measure. Okay, but you have to measure by drawing. And now you can calculate angle R and the time of class is ending. So I am writing answer. Sir, angle of refraction is 26.8. 26.8. 26.8. And tomorrow we will continue the same question at the same time.